All right, ladies and gentlemen, today we are going to look at how to decide bond polarity. So there are a couple of things we need to understand about the word polarity. So let's look at that word. Polarity has as its root a word pole. So you are familiar with a magnet having a north pole and a south pole. So if something has polarity, that means it has poles. A north pole and a south pole. Generally in chemistry we consider north poles positive and south poles negative. So what we're interested in here is whether or not a molecule is going to act like a magnet that has poles. If it does act like a magnet that has poles, then it has polarity. It's the adjective for the noun polarity is polar. If it doesn't act like a bar magnet, then we call it nonpolar. So nonpolar is determined by figuring out what you get when you subtract the numbers. Same with polar. You subtract the numbers, and if it falls within this range, it's going to be polar and act like a magnet. And because a magnet has a positive pole and a negative pole, it has a dipole. Di meaning two, pole, two poles. A positive north pole and a negative south pole. So that's the essence of what today is about. The process is really simple. So if we look here at this picture of a Lewis structure, we can tell that our Lewis structure has for iodine, based on the table right here, a 2.5. At is up here at a 2.2. So we're going to take the bigger number, 2.5, minus the smaller number, 2.2, and we get 0.3. So that falls into the range of being nonpolar. That means it is not going to act like a magnet. It is not going to have a positive end. It's not going to have a negative end. So we would describe this as nonpolar. So now we're going to do the next one. And I thought that I would take the opportunity for the next one to review how to draw these covalent pictures. So if we look at the next one, fluorine is an S2P5, and we get that from right here. You don't have to go to the periodic table to look that up. And then if we look up At is up here. It is also an S2P5. So that means we're going to get 7 electrons from the fluorine because 2 plus 5 makes 7. And we're going to get 7 electrons from the astatine because, again, 2 plus 5 makes 7. And so we add those up and we get 14 electrons for a total. All right, the next step we're supposed to do is draw our skeleton. So we have a fluorine connected to an At. So here's my fluorine connected to my At. And to draw that skeleton, I have used up 2 electrons to make that chemical bond. So I subtract off those 2 electrons needed to make the skeleton. And that means that I end up with 12 electrons left. So I'm going to put 6 here. That gives me 2 above, 2 below, 2 to the left, 2 to the right. So fluorine is happy now. And I still have 6 more dots left because I have a total of 12. So I'm going to put 2 here, 2 there, and 2 there. That used up the other 6. And now I have my picture. So that's a review of how to draw the covalent picture. Now, the next part of this is to realize that fluorine is a 4.0 right here. At is astatine. That's a 2.2. So we subtract 4.0 minus 2.2, and we get 1.8. Okay, that falls in this range. So that means this guy is going to be polar. So when I have my molecule here, because it's polar, it's going to have one end that is positive and one end that is negative. So the number that is higher tells you who the negative is. The number that's lower tells you who the positive is. So this fluorine end is going to be negative, and this astatine end is going to be positive. And so that's my completed picture showing the polarity of that guy. And that, my friends, is all there is to it. So you're going to draw, you're going to subtract, and then if you look at your subtraction answer, you decide whether it's nonpolar with no plus and no minus, or polar with a plus pole and a minus pole.